Objective 2 is to convert from polar coordinates to rectangular coordinates. So if P is a point with polar coordinates r theta, the rectangular coordinates x, y of P are given by x equals r cosine theta and y equals r sine theta. Well, where does that come from? So let's say here I have r, right? This is the point r theta, and I want to figure out my polar coordinates. Well, this would be y, this would be x, right? Sorry, my rectangular coordinates. And I would know that cosine of theta is x over r, and sine of theta is y over r. So that means x equals r cosine theta, and y equals r sine theta. So we get this from our trig identities. So let's find the rectangular coordinates of the point with the following polar coordinates. So I've got 2 pi over 4. So if x equals r cosine theta, x equals r cosine of pi over 4. Well, cosine of pi over 4 is 2 square root of 2 over 2. And pi over 4 is in coordinate 1, so it's positive. So I have x is square root of 2. Then if I have y equals r sine theta, that means y is 2 sine of pi over 4. So y equals 2 times the square root of 2 over 2, which is the square root of 2. So when we convert from polar coordinates to rectangular coordinates, the polar coordinate 2 comma pi over 4 becomes square root of 2 square root of 2. Next, let's convert from rectangular coordinates to polar coordinates. So note that points that lie on either the x or y axis have if I have a point on the x-axis, so when x is a constant and y is 0, that becomes the polar coordinate where this x also is my radius, right? So I have my radius is a and the degree is 0. If I have a point on the y-axis, the positive y-axis, this is the point when x is 0, y is a. A is now my radius, that distance on the y-axis, and my theta is going to be pi over 2, which is 90 degrees. If I have a point on the x-axis where x is negative a and y is 0, well, that's going to become the point with radius a, right? Because radius is always positive, and I've gone 180 degrees from my terminal side, so that's going to be pi, which is 180 degrees. Last, if I have a point on the y-axis that's negative, so negative a, my radius becomes the absolute value of a, right? So that's the distance from our pole, from the origin. And then I'm looking at the degree from my terminal side, which is 3 pi over 4. So when you are given a point who has a 0 as an x or a 0 as a y value, I would imagine envisioning where it is on the xy coordinate plane, because that can really help you determine the value of your theta and the distance of your radius, the length of your radius. So I want to find polar coordinates of a point whose rectangular coordinates are x is 0, y is 2. So when x is 0 and y is 2, I have gone, from my terminal side, I've gone pi over 2 degrees, and my distance is now 2. So that becomes when r is 2, theta is pi over 2. So now I want to know, how do I convert from rectangular coordinates to polar coordinates when the point isn't on an x-axis or a y-axis, but it's in our quadrant? So let's work through a step-by-step example. I have my steps written out in turquoise, teal, I think this is teal. So let's say we want to find the polar coordinates of a point whose rectangular coordinates are 3, negative 3. So x is negative 3, y is negative 3. We are down here. So the first thing you want to do is plot your point. and determine the quadrant it lies in. Remember, quadrant determines our angles. This lies in quadrant 4. Next, we're going to calculate the distance from the origin by using the Pythagorean theorem, right? Our hypotenuse, r squared equals x squared plus y squared. So r is going to equal the square root of x squared plus y squared. So I'm going to take the square root of 3 squared plus the square root of negative 3 squared. That gives me the square root of 18. So r is 3 square root of 2. So we've got one more step. So now I have that r. So we've got one more step. So now I have that r is 3 square root of 2. And because it lies in quadrant 4, that means that it's going to be between negative pi over 2 and 0. So because tan inverse only works in quadrants 1 and 2. Only works in 1 and 2. So I have, quadrants 4 and 1. So if I take tan inverse of y over x, that's tan inverse of negative 3 over 3, which is y over x. So I have tan inverse of negative 1, which would give me the negative pi over 4, right? It could also, so that's going to give us 3 square root of 2 of negative pi over 4. Remember, there are other ways I could have written this. I could have written this at negative pi over 4 as 7 pi over 4, or I could have made my angle, my radius negative, and gone to this angle over here, right? This would have been the point positive 3 square root of 2, 3 over 4. So there's lots of different ways to represent it. So let's work through an example, and I want us to solve this one. So first, let's find the polar coordinates of a point whose rectangular coordinates are negative 2, negative 2. So this is when x is negative 2, y is negative 2. I think we're going to be right about here. And yes, everything's labeled, so you can probably already guess the theta, but let's work through it anyways, shall we? So that's my point. So I need to calculate, and I'm in quadrant 3. So I need to calculate my r. R is the square root of x squared plus y squared, which is the square root of negative 2 squared plus negative 2 squared, which is the square root of 8, which is 2 square root of 2. So my radius is 2 square root of 2. Now I need to determine my theta. So I'm going to take tan of theta, which is y over x. That means I've got tan of negative 2 over 2. So I have tan of theta equals positive 1. And I'm going to, and remember, tan of theta is only defined in quadrants 1 and 4. So I'm going to take tan inverse of both sides. And I get theta equals pi over 4. But that's in quadrant 1. Sorry, I'm here. That's in quadrant 1, right? This is pi over 4. So if I add 180 degrees, or I add pi to that, I'll get to quadrant 3. So I have pi over 4 plus 4 pi over 4, which is 5 pi over 4. So this is the point when x is negative 2 and y is negative 2. I have the point radius 2 square root of 2, theta 5 pi over 4. And that's one representation. Remember, we could have found multiple representations. So here are the steps. I didn't need to include those, but let's talk about the summary, right? This goes over our step-by-steps. There are also answers in our guided notes as to the steps you'd like to follow. So here's how you convert from rectangular to polar coordinates.